Welcome back, everybody. We're continuing on with our practice internal assessment. The second bullet point asks you to develop a general method for proving that the diagonals of the rhombus are perpendicular. What I'm going to do first is, we've got here the diagram that shows A, B, C, D. Remember we said in the upper left-hand corner there is a right-angled triangle. And I want to use that as the foundation of my explanation. So the short sides are B and C, and the hypotenuse, that is side length A. Now we're going to use that as some of our proof. So since I've got a right angled triangle, I know that the square of the two short sides, B squared plus C squared, that's going to equal my A squared. That's just Pythagoras. So now what I'm going to do, I want to prove that the diagonals are perpendicular. We know from previous problems that diagonals are perpendicular if we can show their gradients multiply to -1. So what I did was, the gradient of AC between points A and C, that gradient is C over A plus B. The gradient of BD is C over B minus A. So what I want to show is, if I can take the C over A plus B and times that by C over B minus A, and I get -1. That's what we're looking to do. So let's take that and let's go ahead and get rid of the brackets here on the bottom. A plus B times B minus A gives AB minus A squared plus B squared minus AB equals -1. And of course the C times C, that gives us C squared. Well, the AB minus AB, those cancel, and I'm left with -A squared plus B squared. Well, I'd rather say B squared minus A squared as my denominator. So I've got C squared over B squared minus A squared equals -1. Well, that doesn't exactly do it. Well, let's go back to this Pythagoras bit. Let's see, if I get B squared minus A squared, let's see what that gives me. So I'm going to make B squared minus A squared the subject, which means I'm going to switch these two around. If the A squared comes to the other side, I've now got B squared minus A squared, and if the plus C squared goes to the other side, that gives me the opposite of C squared. Well, now I'm pretty much done, because what I've just shown is I can now substitute this B squared plus A squared, B squared plus A squared. Well, what is this exactly equal to? The opposite of C squared. So now what I have is, by substituting, I can now say, I'm going to take this is where I'm at, I'm going to bring it up here. So now I've got C squared over, let's make that look more like a square. I've got C squared over this B squared minus A squared, I've shown is equal to the opposite of C squared. Does that equal -1? You bet it does. Take any value of C. I'll take 5. 5 squared is 25. Divide that by the opposite of C squared, the opposite of 25. Well, guess what? You've got your -1, and there's a method by which you can prove that the diagonals of that rhombus are perpendicular. Now, I'm going to be up checking my emails into the night, so if there's questions, please ask me. I'll do my best to get back to you with a clear, good explanation, but hopefully that'll help you out. Okay?